Tonight, we follow one single movement. Almost everything out there is turning, from specks of dust to whole galaxies. And all of it turns for the same quiet reason. Nothing here is in a hurry. Our galaxy takes 230 million years to carry the sun once around it. The ground beneath you is turning right now, steadily, and you cannot feel a thing. Let your breathing settle. Let the facts drift past. You are welcome to fall asleep at any point. Fact 1. Almost everything we can see out in space is turning. A grain of dust, a moon, a planet, a star, a whole galaxy. Nearly all of it is going round, quietly and steadily. And none of it is being pushed by anything now. The turning is not something happening to these things today. It is something they were handed long ago by whatever they were made from. Imagine a wheel set going once in an empty room, and then simply never stopping, because there is nothing there to slow it down. Picture that same small idea spread across the whole sky. Every object carrying an inheritance of movement it never asked for and cannot put down. As you rest, there is nothing here that needs keeping up. There is only one movement, repeated at every size, from a speck of dust to the largest things we know of. And so it all keeps turning, resting quietly in the dark. Fact 2. One of the smallest turning things anywhere is a grain of interstellar dust. It measures perhaps a 10,000th of a millimeter across, finer than smoke, a little splinter of carbon or of rock floating in the cold between the stars. And it turns. Out there, with nothing to touch it and nothing to rub against, a grain that was set turning once simply goes on turning. Imagine something far too small to see, drifting in the dark, rolling over slowly and evenly with nobody watching it. Picture the emptiness around it, so thin that the nearest other grain may be a whole room away. So nothing ever knocks it out of step. As you rest, let that be the smallest movement in the sky tonight. Turning without weight, without sound, without any consequence at all. There is an odd comfort in a movement so small that nothing depends on it. And so the grain turns on, resting quietly in the cold. Fact 3. We know those grains are turning because of the way they line up. A dust grain out there is not round. It is lumpy and a little long. And as it turns, it slowly settles into step with the faint magnetic field threading the cloud, taking its time about it, the way a compass needle does. Rows and rows of them end up leaning the same way. Starlight passing through is then dimmed slightly more in one direction than in the other. Imagine the light of a distant star sliding through a drift of tilted specks and coming out the far side, gently combed. Picture someone measuring that faint lean and understanding from it that the dust out there is turning, in a place nobody will ever visit. As you rest, there is something kind in learning of a movement only by the softening of a light. And so the aligned grains hold their tilt, resting quietly in the dark. Fact 4. There is a name for the amount of turning a thing carries, and it is angular momentum. It is not really a formula, only a quantity, in the way that weight and warmth are quantities. It depends on three plain things: how much stuff there is, how far that stuff sits from the middle, and how quickly the whole thing goes round. A heavy wheel carries more of it than a light one. A wide wheel carries more than a narrow one, turning at the same rate. Imagine holding a bicycle wheel by its axle while somebody spins it, and feeling how much movement is stored in that rim. Picture the very same quantity gathered in a cold cloud of gas, far larger than any star, counted up from every drifting speck inside it. As you rest, there is no need to hold the idea firmly, and so the turning is counted, resting quietly in the dark. Fact 5. There is one rule underneath almost all of it. Nothing can create angular momentum, and nothing can destroy it. It can only be handed on. When a cloud shrinks, the same turning has to fit into a smaller space, so the turning speeds up. That single rule lies underneath everything that turns. It works the same way for dust, for planets, for stars, and for whole galaxies, without effort and without exception. Imagine a quantity that cannot be spent and cannot be lost, only passed from one thing to the next, on and on. Picture it moving through the sky the way water moves between vessels, never gaining, never draining away. As you rest, there is no need to remember any of it. It will simply go on being true in the background of everything else. And so the turning is passed along, resting quietly in the dark. Fact 6. The easiest place to watch that rule at work is an ice rink. A skater turning slowly with her arms held wide draws them in against her body, and without pushing against anything at all, she comes round faster. When she opens her arms again, she slows. Nothing was added and nothing was taken away. The same turning simply had to fit into a narrower shape. Imagine that gentle change happening over and over in a quiet rink, arms out, arms in. The seed rising and easing like a slow breath. Picture exactly the same arithmetic in a cloud of gas wider than 1,000 solar systems, drawing itself inward over millions of years. As you rest, let those two pictures sit side by side, the small one and the vast one, doing precisely the same thing. There is comfort in a rule you can watch with your own eyes, and so the turning gathers inward, resting quietly in the dark. Fact 7. It all begins in a molecular cloud, cold, thin, and enormous. The gas in it is colder than almost anything on Earth, so sparse that we would call it a vacuum, and spread across a stretch of space that would hold 1,000 stars. And it turns. Its turning is so slight that a single circuit takes tens of millions of years, which is slower than the word usually means. Imagine a body so large and so faint that you could pass through its edge without noticing you had entered anything. Picture it going round once in the time it takes a mountain range to rise and wear back down again. As you rest, that is the pace we are starting from. A movement you could never detect while watching, only afterwards. There is peace in a beginning as unhurried as that. And so, the great cloud turns once, resting quietly in the cold. Fact 8. The cloud did not have to be given its turning by anything dramatic. It sits inside a galaxy that is already going round, and the galaxy drags at it very gently. The near side and the far side travel at slightly different speeds, so the cloud is quietly sheared. Streams of gas drift past it and nudge it. Old, faded shells of gas from stars that died long ago lean on one edge more than the other. Imagine countless small pushes arriving from every direction over millions of years, never lining up perfectly, never quite cancelling out. Picture the leftover, the tiny difference that remains once all of them have been added together. As you rest, know that a perfect zero simply never happens out there, and that a crumb of turning is all this story ever needed. There is something restful in a beginning so small. And so the cloud inherits its lean, resting quietly in the dark. Fact 9. That crumb is enough because the cloud is going to shrink by an enormous factor. Gravity pulls it inward over many millions of years. And as it draws in, the same rule takes over. The same turning, held in a smaller space, comes round more quickly. A movement too slight to measure at the start becomes the main movement at the end. Imagine a barely perceptible drift, so faint it looks like stillness, being folded in on itself again and again until it is unmistakable. Picture the cloud tightening slowly, patiently, with no moment at which anything changes suddenly. As you rest, there is nothing being forced here, only a shape getting smaller, and a movement that had nowhere else to go. There is a soft inevitability in it, more like settling than like anything happening. And so the faint turning grows, resting quietly in the dark. Fact 10. And here is what that turning does to the shape. Along the axis, where the movement is not, gas falls straight inward without anything to hold it up. Out along the sides, the turning carries material around instead, and it settles far more slowly. So, the collapse is lopsided. The cloud comes down quickly from above and below, and lingers around its own middle. Imagine a ball of soft dough spinning gently on a table, sagging at the top and spreading at the sides until it is a disc. Picture that same flattening taking 1,000,000 years, so gradual that at no point could you have seen it happening. As you rest, let that shape settle in your mind. A wide, thin, unhurried plate of gas where a shapeless cloud used to be. There is a quiet order in a shape nothing designed. And so the cloud lies down flat, resting quietly in the dark. Fact 11. That is why the flat disk is one of the commonest shapes in the universe. Wherever something turns while it draws itself together, the same thing happens. It thins out along the axis, spreads along the middle, and ends up a plate. Young stars are ringed by disks of dust. Giant planets carry disks of ice and rubble. Spiral galaxies are disks. Even the material gathering around a black hole arranges itself the same way. Imagine one simple recipe, followed at sizes that have nothing else in common, giving the same wide, thin answer every time. Picture those plates stacked in your mind from smallest to largest, all lying flat, all turning the same patient way. As you rest, the same wide shape appears again and again, at every size, always for the same reason. There is a restfulness in repetition on this scale, and so the disks turn on, resting quietly in the dark. Fact 12. Around a newly formed star, that plate is called a protoplanetary disk. It stretches out perhaps 100 times the distance from the Earth to the Sun. And it is thin for its width, more like a plate than a ball. Near the star, it is warm enough to keep dust dry. Further out, it is cold, and everything that can freeze has frozen. It lasts a few million years, and then it is gone. Imagine a wide floor of warm dust turning slowly around a young light, each ring of it going round at its own pace. picture the faint haze in it, thinning towards the edges, softening the star behind it. As you rest, let that be the room the planets are made in. Dim, warm near the middle, and very slow. There is calm in a place with so much time in it. And so the young disk turns, resting quietly in the dark. Fact 13. We have seen this with our own instruments, so it is not a guess. An array of radio dishes standing on a high, dry plateau has photographed disks around young stars, and the pictures show neat concentric rings with dark gaps between them, like a record laid flat or ripples in still water. The gaps are most likely swept clear by planets already forming inside them. Imagine those first images arriving quietly on a screen at night, and someone realizing they are looking at the thing that had only been drawn on blackboards before. Picture the rings themselves, soft, orange, evenly spaced, turning far too slowly for any camera to catch the movement. As you rest, know that we simply looked, and it was there. There is a plain satisfaction in a thing that turns out to look the way it should, and so the rings hold their circles, resting quietly in the cold. Fact 14. Inside the disk, the dust begins to gather. Grains drift into one another so gently that they do not bounce. They stick and become clumps, and the clumps sweep up more grains as they go. Every one of them keeps the direction of movement it already had, because there is nothing to take it away. Imagine a soft snowfall that never lands, each flake joining the next in midair, all of them traveling the same way around, none of them ever coming to rest. Picture the first centimeter-wide crumbs of a future planet, drifting slowly in a warm haze, already going round in the same direction the whole disk goes. As you rest, there is no drama in this part, only things touching and staying and carrying on together. There is comfort in beginnings that involve no force at all. And so the clumps drift and gather, resting quietly in the dust. Fact 15. As the clumps grow into small bodies, they start to turn on their own. The reason is simply geometry. Two bodies almost never meet head-on, dead center. One arrives a little to the side of the other, and that off-center touch gives the pair a small nudge of turning that they both keep. Do that a great many times over a very long while, and every body ends up rotating. Imagine two soft snowballs meeting shoulder to shoulder rather than face to face, and rolling slowly onward together. Picture a whole disk of them, each one turning a little differently, each one having gathered its turning from wherever it happened to be touched. As you rest, none of this was decided or aimed. It is only what happens when things meet slightly to one side. There is a gentleness in an origin so ordinary. And so the small bodies turn, resting quietly in the dark. Fact 16. This is why our own planets travel the way they do. All of them go around the sun in the same direction, and all of them keep to very nearly the same flat plane, close enough that you could lay the whole system on a tabletop. That is not a coincidence, and not a preference. It is the shape of the disk they were made in, kept without alteration for 4.5 billion years. Imagine a memory that nothing has needed to maintain. No correction, no upkeep, nothing checking that it holds. Picture the planets going round in their old order, wide apart, unhurried, each one moving the way the dust around it moved before any of them existed. As you rest, let that be the oldest thing here, a direction, remembered by everything that was there. And so the planets keep the plane, resting quietly in the dark. Fact 17. Their own turning. The spin of each planet on its axis comes from the same disk, but that memory is a far more delicate one. A planet is small compared with its orbit, so it takes much less to alter it. One large body arriving off-center early on can tip an axis over or slow a rotation down, and afterwards the planet keeps the new arrangement just as faithfully as it kept the old. Imagine a set of tops, all started off together, and one of them being brushed once, quite early, and going on differently ever after. Picture the rest of them continuing untouched, upright, turning the way they always did. As you rest, a few of the worlds out there do lean strangely, and each one has simply kept what it was given. There is no urgency in any of it, and so the axes hold their angles, resting quietly in the cold. Fact 18. There is one oddity in our system that is rarely mentioned. The Sun holds 99.8% of all the mass here. Everything else, every planet and moon and stone, is the small remainder. And yet the Sun carries less than 1% of the system's turning. Almost all of it is out in the wide orbits of the 4 giant planets, and most of that belongs to the largest of them. Imagine a household where one member owns nearly everything, and the movement of the place belongs almost entirely to the others. Picture the Sun going round its own axis calmly in the middle, while the real turning of the system circles far outside it. As you rest, there is no conflict in this, only a quantity that ended up somewhere other than the mass did. There is a quiet strangeness worth keeping, and so the balance sits far out, resting quietly in the dark. Fact 19. The Sun did not keep its share, and we have a fair idea of where it went. A young star is wrapped in a magnetic field that reaches out into the disk around it, and the gas out there is held by those lines the way a weight is held on a long string. The star turns, the field drags the gas along, and the gas carries turning away with it as it leaves in the stellar wind. Imagine a long, slow letting go, going on for millions of years, with nothing coming back. Picture the young Sun easing down through it, turning a little less quickly with every age that passed, settling gradually towards the calm, even pace it keeps today. As you rest, that is the same rule again, working in the other direction. The turning was not lost, only handed outward. And so, the Sun let its turning go, resting quietly in the cold. Fact 20. So the turning is older than the Sun. It was in the cloud before there was a star, and it was in the dust before there was a cloud. And every time something has gathered itself together since, it has taken a share and passed the rest along. Nothing here began it, and nothing is going to end it. Imagine a single movement traveling from dust to disk to planet to star, changing hands, never changing amount. Picture the gap between those two beginnings. The cloud was already turning for millions of years before the Sun ever lit up. As you rest, the the same inheritance runs upward through larger and slower things, and the nearest of them all is the ground you are lying on. There is no need to go anywhere to see it, and so the inheritance moves on, resting quietly in the dark. Fact 21. Measured against the distant stars, the Earth comes all the way around in 23 hours, 56 minutes and 4 seconds. The day we actually live by is a little longer than that. While the planet turns, it also slides a short way along its orbit, so the Sun needs a few extra minutes to arrive back overhead. Imagine a slow dial with two hands set almost together, one keeping time with the stars and one keeping time with the Sun, easing apart by a few gentle minutes every night. Picture the same stars rising a touch earlier each evening, drifting back across the year without ever losing their place. As you rest, let those few minutes be the smallest debt in the world, settled quietly every single night. There is something kind in a clock this old that has never needed winding. And so the Earth comes round again, resting quietly in the dark. Fact 22. At the equator, the ground carries you along at something like 1,670 kilometers an hour, and nothing about it can be felt. The motion is perfectly even. There is no push in it and no shudder. And everything around you, the air, the sea, the walls of the room, is traveling at exactly the same pace. Imagine a train so smooth that a glass of water on the table never trembles. And then imagine that train being the whole world. Picture the ground beneath you covering all that distance while you lie still and do nothing at all. As you rest, let the speed stop meaning speed and become something closer to stillness, since nothing here is overtaking anything else. There is deep comfort in a motion so steady that your body has never had any reason to notice it. And so, the ground carries you on, resting quietly in the dark. Fact 23. All that patient turning has slowly pressed the planet out of shape. The Earth measures about 42 kilometers more across the equator than it does from pole to pole. So, it is not quite a sphere, but a very slightly flattened one. The bulge is not damage and not an accident. It is simply the shape a turning thing settles into, given enough time. Imagine soft clay easing outward at its middle on a slowly spinning wheel, while the potter's hands stay perfectly still. Picture the planet holding that gentle swell for billions of years, never sharpening, never sagging back. As you rest, let the difference stay small in your mind. A few dozen kilometers spread around a whole world, a change no window would ever show you. There is a quiet honesty in a shape that records its own movement and says nothing about it. And so the Earth keeps its soft equator, resting quietly in the dark. Fact 24. Because of that gentle bulge, the point on the surface that lies farthest from the center of the Earth is not the summit of Everest. It is the top of Chimborazo, a broad old volcano in Ecuador, almost exactly on the equator. Everest stands higher above the sea, but Chimborazo begins from ground that the turning has already carried outward. Imagine two mountains measured not from the water, but from the middle of the world, and the shorter one quietly coming out ahead. Picture that snow-covered dome sitting at the widest part of the planet, lifted a little further into space by nothing more than the length of a day. As you rest, let both mountains keep their titles, each true in its own way, neither taking anything from the other. There is a mild pleasure in something that rearranges nothing and simply adds to what is already there. And so Chimborazo leans a little further out, resting quietly in the dark. Fact 25. The axis the Earth turns around is not upright. It leans by about 23.5 degrees, and it holds that lean all the way around the Sun, pointing in the same direction the whole year through. That single tilt is the entire reason there are seasons. Imagine the planet as a slowly turning top set a little off vertical, its northern half leaning towards the light for half of the orbit and away from it for the other half. Picture the sunlight arriving at a steeper angle in one season and a shallower one in the next, warming the ground simply by falling on it more directly. As you rest, let the year become one long, gentle nod rather than a set of separate weathers. There is order in it, the same order every time, arriving without anyone arranging anything. And so the tilted world leans on around the Sun, resting quietly in the dark. Fact 26. Where the lean came from, we cannot say for certain, but the most likely answer is very old. Early in the life of the solar system, something large is thought to have struck the young Earth, knocking it off upright and throwing out the material that later gathered into the Moon. The tilt and our companion in the sky may well be two halves of the same event. Imagine that meeting happening slowly. Two warm bodies of rock easing together over long minutes rather than colliding all at once. Picture the Earth settling into its new lean afterwards and simply keeping it, without correction, for 4.5 billion years. As you rest, let the story stay gentle and a little uncertain, the way old stories are. There is comfort in an answer that is probably right and in no hurry to be proven. And so the world holds the angle it was given, resting quietly in the dark. Fact 27. The Moon helps hold that lean in place. Its steady pull smooths out the small tugs the other planets give us, so our tilt only drifts by a couple of degrees over very long stretches of time. Without the Moon, those wanders would be wider and less predictable. Imagine a hand resting lightly on the top of a slowly turning globe, not gripping it, not steering it, only keeping it from nodding too far. Picture that quiet influence working across billions of years through every season the world has ever had, asking nothing and changing nothing in particular. As you rest, let it be a companionable thing rather than a rescue. The Moon simply keeps us company, and the tilt stays as it is. There is something settling in, knowing that the shape of our year is looked after by something so far away. And so the Moon steadies the lean, resting quietly in the dark. Fact 28. The axis does not stand still. It traces a wide, slow circle in the sky, and one full turn takes about 26,000 years. The lean stays the same, only the direction it points slowly changes. Imagine a spinning top that has begun to lean, and the way its stem sweeps out an unhurried cone, while the top itself keeps turning. Picture the same motion in the Earth, so slow that a lifetime of watching would move the pole by about the width of a finger held at arm's length. As you rest, let it be one of the slowest movements anyone noticed, long before the telescope. Greek astronomers found it by setting their star records beside much older ones and seeing everything sitting a little out of place. There is a peace in change that takes longer than any civilization and asks nothing of the people inside it. And so the axis sweeps its long circle, resting quietly in the dark. Fact 29. One consequence of that slow circle is that the North Star is only ours for a while. 5,000 years ago, the axis pointed near a different star, Thuban, in the constellation of the Dragon, and the builders of the oldest tombs took their bearings from it. In about 12,000 years, the closest bright star to the pole will be Vega. Imagine the pole of the sky as a very slow hand crossing a great dial, resting near one star for a few thousand years before moving on to the next. Picture Polaris drifting gently away from its post, long after everyone who used it has gone. As you rest, let the sky be something that changes too, just far too slowly to watch. There is a soft kind of patience in stars that take turns across the ages. And so the pole moves on to the next one, resting quietly in the dark. Fact 30. Laid over that great circle are two much smaller motions. The moon's pull adds a slight nodding of the axis that repeats about every 18.5 years. And the axis itself drifts a few meters sideways in a loop that comes round roughly every 433 days. Imagine a wide, slow sweep with the faintest tremble at the very tip of it. Picture the poles wandering across the ice in a slow, irregular shape, no wider than a small room. A drift you could cross in a few paces. As you rest, let these be the breathing of the axis, rather than any kind of fault. Small, regular, always returning to where they began. There is comfort in a wobble that has nowhere to go and always comes back. And so, the axis breathes as it turns, resting quietly in the dark. Fact 31. Hang a heavy weight on a long wire. Set it swinging, and it will keep swinging in the same flat plane, because nothing is turning it. The floor underneath, however, is turning. Over the hours, the swing appears to sweep slowly around the room, and this was the first plain demonstration that the Earth turns, made without looking at the sky at all. Imagine a great brass bob easing back and forth under a high dome, tracing the same line again and again, while the tiles beneath it quietly slide out of alignment. Picture a small marker being knocked over every 20 minutes or so, one after another, all the way around the circle. As you rest, let that swing keep its patient time, the same arc, the same pace, the room turning underneath it. There is calm in a thing that stays true while everything around it moves. And so the pendulum swings on, resting quietly in the dark. Fact 32. A wheel that is already turning remembers which way its axis points and gently resists being tipped. That is the same stored-up turning, now small enough to fit in a hand. Ships steady themselves with it, and aircraft find their level by it. The phone beside your bed feels every turn you give it as well, though its version has no wheel in it at all, only a sliver of silicon trembling. Imagine a brass wheel humming in its gimbals, keeping its direction while the case around it tilts this way and that. Picture how the whole world could turn around such a wheel, and it would carry on pointing at whatever it was given. As you rest, let that stubbornness be a comfort rather than a force. Nothing is fighting anything. It is simply keeping what it already has. There is quiet reliability in it. And so the wheel holds its direction, resting quietly in the dark. Fact 33. Because the ground turns, anything that travels a long way across it drifts slightly to one side. Air moving north or south, ocean currents crossing whole basins, a long flight crossing an ocean. All of them lean a little, right in the northern half of the world and left in the southern. The effect is small and only shows on things that move far and slowly. It is far too weak to decide which way water leaves a sink. That story is not true, and the shape of the basin decides it instead. Imagine a line drawn on a slowly turning plate, straight from the hand that draws it, curved by the time the plate comes round. Picture the sea taking that same lean, month after month, across a whole ocean. As you rest, let it be the mildest of nudges. There is something gentle in a force this patient. And so the long paths curve, resting quietly in the dark. Fact 34. Given enough room, that mild nudge gathers weather into circles. A cyclone is one of the largest turning things on Earth that can be seen whole. Hundreds of kilometers of cloud wound into a slow spiral, coiling one way in the north and the other way in the south, because the ground beneath is turning under it. Imagine watching one from far above, unhurried, its arms taking hours to swing round the quiet center. Picture the whole system drifting across open water no faster than a bicycle, holding the same wide shape the entire way, hour after hour. As you rest, let the storm stay far off and silent, a white spiral seen from orbit rather than felt from below, a shape rather than a sound. There is a strange calm in weather viewed from high enough that all its hurry disappears. And so the great spirals turn above the sea, resting quietly in the dark. Fact 35. The moon is slowly taking some of our turning away. Its pull raises the tides. The water drags a little against the ocean floors, and that endless rubbing gently slows the turning. The day lengthens by roughly 1 3/4 milliseconds a century, a change no household clock could show. We know it from two patient sources: laser light bounced off mirrors left on the moon, and eclipses recorded thousands of years ago, whose shadows no longer fall quite where they should. Imagine the tide coming in tonight and carrying off so little turning that 100 years of it would still not add up to a single blink. Picture that exchange repeating every day since the oceans first existed. As you rest, let it be a slow handing over rather than a loss, since the turning is not gone, only moved. There is a mildness in a break this soft. And so the tides ease the planet along, resting quietly in the dark. Fact 36. Run that slow handing over backwards, and the days get shorter. 1 billion years ago, the Earth came around in something close to 19 hours, and the moon hung nearer in the sky. We can read this in stone. Some old sediments were laid down in fine, rhythmic layers that follow the slow swing of the Earth's orbit, and the spacing of those bands can be counted like the rings of a tree. Younger rocks add their own record. Shells and corals from a few 100 million years ago carry growth lines that count out a shorter day still. Imagine sitting with a piece of banded rock and counting quietly until the shape of a much older year appears in your hands. Picture a shorter day on that ancient coast, the light coming round more briskly over an empty shore. As you rest, let the past be something written down carefully and simply, waiting to be read. And so the old days lie counted in the stone, resting quietly in the dark. Fact 37. It is tempting to say the Earth is simply slowing down, and that is not quite right. The long trend does run towards longer days, But the planet also wobbles around that trend, and lately it has been running a little fast. Since about 2020, we have recorded the shortest days of the whole atomic clock era, several of them more than a millisecond under the standard day. And the run now appears to have passed its peak and eased back. Imagine a very old pendulum that keeps beautiful time across centuries while drifting by a hair from one decade to the next. Picture the planet doing the same, never off by anything a person could feel. As you rest, let the wobble be reassuring rather than strange. This is what a real, living, slightly uneven world does. And so the days come and go a hair unevenly, resting quietly in the dark. Fact 38. The reason the length of a day drifts is that the planet keeps very slightly changing shape. Molten metal shifts deep in the core. Water moves from one ocean basin to another. Great winds pile up against the mountains. Ice melts at the poles and the sea spreads it around. When more of the world's mass sits nearer the axis, the whole planet turns a shade faster, and when it moves outward, a shade slower. It is the same trade every skater makes with their arms, carried out on a scale of continents. Imagine the Earth breathing in and out by fractions of a millimeter, always adjusting, never settling. Picture the day answering each of those small rearrangements. As you rest, let the planet be something soft and responsive rather than a fixed stone. There is intimacy in a world whose clock listens to its own weather. And so the Earth adjusts itself, resting quietly in the dark. Fact 39. Atomic clocks keep steadier time than the planet does, so now and then our timekeeping is nudged back into step. That is what a leap second is. An extra second slipped in at the end of a day, added a couple of dozen times since the 1970s to let the Earth catch up. Lately, the discussion has turned the other way. Because of that, a second may one day have to be taken out instead. And rather than face it, the world's timekeepers have already agreed to stop adding leap seconds altogether within the next decade, and simply let the difference gather. Imagine the world's clocks pausing together for one extra second on a winter night, every dial holding the same reading twice. Picture almost everyone sleeping straight through it. As you rest, let that borrowed second be yours, spent doing nothing. There is a small kindness in a system built to follow the ground rather than correct it. And so time is quietly adjusted, resting quietly in the dark. Fact 40. Deep at the center, there is a ball of solid iron, and it turns very nearly with the rest of the planet, though not exactly. For years it seemed to run slightly ahead. More recent work suggests its drift has slowed, and may even have swung gently back the other way. We are still working it out, and the answers come slowly, read from the way earthquake waves arrive after passing through the middle of the world. Imagine that inner ball turning in warm darkness, held in liquid metal, keeping almost perfect step with everything above it. Picture the faint difference between them, a fraction of a degree gained or given back over a human lifetime, deep beneath everything anyone has ever built. As you rest, let the unanswered part of it stay comfortable, the way an unfinished book on the bedside table is comfortable. And so the heart of the Earth turns with it, resting quietly in the dark. Fact 41. The moon keeps one face turned towards us. And it does that because it turns exactly once for every trip it makes around the Earth. Imagine walking slowly around a chair while keeping your eyes on the seat. You are turning as you walk, one full turn each lap, and yet the chair never sees your back. Picture the moon doing precisely this. One patient turn for every circuit, month after month, for longer than there have been oceans on this side of the gap. As you rest, know that this is not a coincidence and not luck holding it in place. It is a result, the outcome of a very long and very gentle settling. There is nothing frozen about it either. The moon is turning right now, steadily, at exactly the pace that keeps its far side out of sight. And so the same soft grey face looks down on us, unhurried and even, resting quietly in the dark. Fact 42. The way it settled is simple. Earth pulls a little harder on the near side of the moon than on the far side. So the moon is gently stretched along the line between us. Imagine a soft ball squeezed a fraction out of round and held that way for ages. Picture what happens when such a body turns underneath its own bulge. The stretched part has to travel through the rock, and rock working against rock warms and gives up a little motion. Picture that drag repeating, turn after turn, taking a little turning away each time until the rotation matches the orbit and the bulge no longer has to move. As you rest, let the softness of it stay with you. There is a name for the ending: tidal locking. It is one of the commonest ways a body hands its turning outward. And so the moon turns once each lap and no faster, settled and slow, resting quietly in the dark. Fact 43. Even so, we do not quite see half of the moon. Over a month, about 59 parts in every 100 of its surface come into view, because the moon rocks very slightly as it goes. Imagine a face nodding and tilting in its sleep, the smallest of movements, never waking. Picture the reason for it. The orbit is not a perfect circle, so the moon runs a touch ahead of its own turning at one end of the loop, and a touch behind at the other. Its axis leans a little as well. Each of these lets us look a short way past one edge, and then past the other. As you rest, let that rocking be the gentlest motion in the sky, a few degrees back and forth over weeks. There is a name for it too: libration. And so the moon sways almost imperceptibly as it goes, patient and mild, resting quietly in the dark. Fact 44. The moon is also drifting away from us by about 3.8 centimeters each year. We know the figure that well because mirrors were left on the surface and laser pulses are still bounced off them. Imagine the gap widening about as fast as a fingernail grows and by the height of a room over a lifetime. Picture where that motion comes from. It is the same turning the Earth is slowly giving up, arriving in the moon's orbit. Nothing is lost anywhere in the exchange. The turning simply moves house, out of the spinning of one body into the path of another. As you rest, let the two halves of the story sit together. Our days growing longer by a sliver each century, the moon easing outward by a sliver each year. There is no ending to hurry towards. And so the moon draws away by a fingernail's growth each year, calm and unhurried, resting quietly in the dark. Fact 45. Locking can also work both ways at once. Pluto and its large moon Charon each keep one face permanently turned towards the other, going round in step. Imagine two dancers holding each other at arm's length, circling a point in the empty space between them, neither one ever turning away. Picture the sky from the surface of Pluto. Charon sits in one place and stays there. It never rises and never sets. It hangs above the same patch of ground, going through its phases without moving from the spot, while the far half of the world never sees it. As you rest, let that be the stillest sky in the solar system, a moon fixed in place and brightening slowly over days. There is a tidiness to it. The two have finished handing their turning back and forth, and there is nothing left for either of them to hand over. And so, Pluto and Charon hold each other in view, settled and even, resting quietly in the dark. Fact 46. Mercury did not settle in quite the same way. It turns 3 times for every 2 trips it makes around the Sun. A steady 3-to-2 resonance held in place by the long shape of its own orbit. Imagine a slow wheel that drops into a groove every second lap, then holds there, lap after lap, for the age of the solar system. Picture what that arrangement does to a day. Because the turning and the orbiting are so nearly in step, the Sun needs about 176 of our days to travel from one noon to the next. A single day there lasts exactly 2 of the planet's own years. As you rest, let the pace of that sky settle over you. Sunlight creeping across bare rock, shadows taking weeks to shorten. There is nowhere in it that anything hurries. And so, Mercury turns 3 times for every 2, exact and unbothered, resting quietly in the dark. Fact 47. For a long while, we believed Mercury kept one face to the Sun forever, the way the Moon keeps one face to us. It was a reasonable idea, and it stood for the better part of a century. Then, in 1965, astronomers aimed radar at the planet and listened for the echo coming back. Imagine a faint returning signal, spread very slightly in pitch, because one edge of the planet is turning towards us and the other away. Picture the answer sitting there in that small spreading, waiting to be read. The world was turning, and turning at its own particular pace. As you rest, let the correction be a soft one. Nobody had been careless. There is only a picture that was held gently, then set down and replaced when a better one arrived. And so Mercury turned out to be turning after all, mild and unhurried, resting quietly in the dark. Fact 48. Venus turns more slowly than any other planet in the solar system. One full turn on its axis takes about 243 of our days, while a whole trip around the Sun takes about 225. The day is longer than the year. Imagine a world that comes back to the same place in its orbit before it has finished coming back to the same place in its turning. Picture the 2 motions almost abandoning their usual order, the slower one belonging to the planet itself, the faster one belonging to the whole long path around the Sun. As you rest, let that inversion be a curiosity rather than a puzzle to solve. Nothing there is straining. There is simply a body that has lost nearly all of its turning over a very long time, and now moves at the pace of a slow clock hand. And so Venus turns beneath its clouds, heavy and slow, resting quietly in the dark. Fact 49. It also turns the other way. Almost everything in the solar system turns in the same direction, inherited from the disk it all formed in, and Venus goes against that grain. Seen from high above the northern side of the system, it turns backwards. On Venus, the Sun comes up in the west and goes down in the east. Imagine that slow, reversed sunrise, glowing dimly through cloud, taking days to arrive. Picture how the 2 motions combine. Because the planet turns one way while it travels the other, the Sun works its way round the sky in about 117 of our days, shorter than either the turn or the year. As you rest, let that be a sky with its own private arithmetic, unhurried in every direction at once. There is no drama in it, only a different answer. And so Venus turns backwards under its clouds, even and patient, resting quietly in the dark. Fact 50. Why it goes that way is something we have not settled. One idea is that Venus was tipped over early on, knocked almost completely upside down, so that a perfectly ordinary turn now looks reversed to us. Another is that its thick, heavy atmosphere dragged on the planet for billions of years, tides in the air working against tides in the rock, until the turning slowed, stopped, and eased back the other way. Imagine either story running at its own enormous pace, far too slow for anyone to watch. Picture both of them sitting side by side in the work, neither one ruled out. As you rest, let the open question be a comfortable place to lie down in. There is no rush to close it. We are still not sure, and the planet keeps turning either way while we think about it. And so, Venus goes its own direction, quiet and unexplained, resting quietly in the dark. Fact 51. One planet keeps almost exactly our own rhythm. A day on Mars runs 24 hours and 39 minutes, and its axis leans over by about 25 degrees, a shade more than ours. Imagine a day there running alongside a day here, the two of them slipping apart by only a little over half an hour. Picture a year of mornings on that world, arriving a touch later each time, drifting slowly out of step with ours, and then, eventually, back. Picture the seasons, too, following from that lean in the same way ours do. One hemisphere tilting into the light, while the other tilts out. One difference, though. Mars has no large moon to steady it. So over millions of years, its lean wanders far more widely than ours ever does. The same tilt, held far less firmly. As you rest, let it simply be a neighbor keeping a familiar pace. There is nothing strange about it at all, only the turn itself. And so Mars turns at very nearly our own speed, tilted much as we are, steady and unremarkable, resting quietly in the dark. Fact 52. Jupiter, the largest planet in the system, has the shortest day in it. One turn takes a little under 10 hours. Imagine a body wide enough to hold more than 1,000 Earths coming all the way round while a single night passes here. Picture what that does to its shape. The middle is carried outward and the poles are drawn in, so the planet sits visibly wider across the waist than through the ends. As you rest, let the enormity of the motion be softened by how it looks from outside. From a distance, nothing appears to be moving at all. The bands hold their places, the colors barely shift from one week to the next, and the whole slow-seeming globe has been turning at very nearly this pace for longer than there has been dry land here to look up from. And so Jupiter comes round again a little under every 10 hours, wide and even, resting quietly in the dark. Fact 53. That turning is also what draws the planet's face into stripes. On a spinning world, air moving north or south is gently pushed sideways so it cannot cross the globe freely and is combed instead into long lanes that run parallel to the equator. Imagine cream poured into coffee and drawn out into long rings rather than swirls. Picture Jupiter's belts and zones as exactly that. Winds wrapped all the way around the planet, some running one way and some the other, each holding to its own latitude for years at a time. Some of them have kept their edges for as long as we have been watching. As you rest, let the pattern be the point. There is nothing painted on that surface, The stripes are simply the shape the atmosphere takes when a very large body turns beneath it. And so the bands lie in their lanes and go round with the planet, ordered and unhurried, resting quietly in the dark. Fact 54. Saturn's day was, for a long time, difficult to measure. A gas planet has no solid ground to follow, no crater or mountain to watch coming round, and its clouds drift at their own speeds rather than the planet's. The answer came from the rings. Imagine the interior of the planet swaying very slightly, the way any large body does, and those slow tremors reaching outward and setting faint ripples running through the ice. Picture the rings acting as a kind of seismograph, holding a record of the planet's own rhythm in their waves. As you rest, know what the reading came to: 10 hours, 33 minutes and 38 seconds. Older books give a different figure. This is the one the waves settled on. There is a quiet elegance in it, a world that could not tell us its day directly, so its rings answered instead. And so Saturn turns on the time its rings keep, patient and exact, resting quietly in the dark. Fact 55. All that turning has left its mark on the shape of the planet. Saturn is the flattest planet in the solar system. Measured across the equator, it is about 1/10 wider than it is from pole to pole, a difference plain enough to see in any decent photograph. Imagine a drop of oil turning slowly in water, spreading gently at the middle until it sits wider than it is tall. Picture Saturn doing the same thing without any hand involved, its own turning carrying the light outer layers away from the axis while gravity holds everything in. The planet is mostly light gas, and light gas gives way more readily than rock. As you rest, let the planet's shape read as a record rather than an accident. There is a turn written into that flattening, one that has been going on unchanged for billions of years. And so Saturn sits a little wider than it is tall, softened and even, resting quietly in the dark. Fact 56. Uranus lies on its side. Its axis is tipped by about 98 degrees, which is a little past a right angle. So the planet does not stand upright on its path around the Sun. It rolls along it. Imagine a spinning top laid down on a table, still turning, only now turning flat instead of tall. Picture what that does to the light. For part of the long orbit, one pole faces the Sun almost directly, and for part of it, that same pole faces away. And since a year there lasts about 84 of hours, each of those stretches runs for roughly 42 years. 4 decades of daylight, then 4 decades of night. As you rest, let that be the slowest sunrise anywhere in the system. There is no flicker to it, no rhythm of days at the poles at all. And so Uranus rolls along its path on its side, tilted right over, resting quietly in the dark. Fact 57. How it came to lie that way is not something we can watch, only reconstruct. The likeliest account is an early collision, something large arriving while the planet was still young and knocking its whole axis over. The clue that points that way is a quiet one. The rings and the larger moons are tilted along with the planet, sharing its lean rather than circling the old upright plane. Imagine a whole household leaning together at the same angle, everything on the shelves keeping its place. Picture what that has to mean about timing. The tipping happened early, before the moons and rings had properly settled into their present arrangement. As you rest, let it be a likelihood rather than a certainty. There is a great deal we can read from an angle, and still some things we cannot. And so Uranus keeps the lean it was given long ago, holding it steadily, resting quietly in the dark. Fact 58. The rings of Saturn look like a solid sheet, and they are nothing of the kind. They are countless separate pieces of ice, most of them smaller than a hand. Each one on its own orbit, and each obeying the plain rule that the closer a body sits to a planet, the faster it goes round. Imagine a drift of leaves on still water, the ones nearer the middle coming round more often than the ones out at the rim, quietly and endlessly, with nothing ever drawing level. Picture the whole disk slipping past itself, layer by layer, inner ice quietly overtaking outer ice, the pattern holding while nothing about it stays in place. As you rest, consider the gaps as well. Some are held open by distant moons whose tug arrives in step with certain orbits. Others have a small moon of their own, sweeping its own lane clear as it goes. There is order in it, but it is order made of pieces. And so the rings turn at 1,000 different speeds at once, layered and smooth, resting quietly in the dark. Fact 59. Among the small bodies, turning takes whatever pace it happens to have inherited. Some asteroids come round in a couple of hours, others take days, and a few take weeks to complete a single lazy turn. Out past Neptune sits Haumea, which comes round once in a little under 4 hours. Its day is among the shortest of any sizable body we know of, and it is fast enough that its own turning has pulled it out of round entirely, stretching it into a long oval, something like a melon rather than a ball. Imagine a lump of rock and ice held in that shape by nothing but its own motion. Picture it going end over end out there, catching a little sunlight on each pass. As you rest, notice what the shape is telling you. There is no sculptor involved, only the turn. And so, Haumea goes round, stretched by its own spinning, patient and cold, resting quietly in the dark. Fact 60. The quietest hand of all belongs to sunlight. A small body warmed on one side re-radiates that heat away as it turns, and because its surface is uneven, the heat leaves a little more strongly in some directions than others. Imagine a push so slight that no instrument on a table could register it. Picture it applied without pause on every part of every orbit for millions upon millions of years, until an asteroid that once turned in a day is turning in a few hours, or has been eased almost to a standstill. As you rest, let that be the gentlest version of the same story. There is no source of turning anywhere that was not handed over by something else. Even light can pass a little of it along. And so sunlight leans on the small bodies without a sound, patient beyond measure, resting quietly in the dark. Fact 61. The sun turns, but not the way a solid ball turns. Its equator comes around once in about 24.5 days, while the gas far to the north and south takes closer to 34. Imagine a wide, slow whirlpool of glowing gas, its middle easing ahead, while its upper and lower reaches trail gently behind. Picture two small dark marks setting out side by side, one near the waist of the sun and one much higher up, and drifting steadily apart over the following weeks until one has quietly slipped a whole turn ahead of the other. As you rest, let there be no strain in this, no tearing, no seam where the two speeds meet. There is only gas sliding past gas, the way it has done for a very long time, with nothing solid anywhere in there to insist that every part keeps step. And so the sun turns at many speeds at once, unhurried and unbothered, resting quietly in the dark. Fact 62. We learned this by watching spots. In the 1800s, an English astronomer named Richard Carrington drew the same dark marks day after day and found that the ones nearer the equator came around noticeably faster than the ones further up. Imagine a man at a small telescope, tracing shapes onto paper every clear morning for years on end. Picture the counting he began, still running today. One solar turn after another ticked off in an unbroken line since the 1850s. As you rest, know that we now listen as well as look. Sound waves move through the body of the sun and come back carrying word of how each layer inside is turning. There is something restful in a measurement made slowly, by hand, and then gently confirmed a century later by other means. And so the sun keeps its long count of turns, patient and unbroken, resting quietly in the dark. Fact 63. Because the middle of the sun runs ahead of the rest, the magnetic field threaded through it cannot stay straight. Imagine a single line of thread laid from pole to pole across a turning ball whose waist moves faster than its shoulders. Picture that thread being drawn out sideways, wrapped around and around, wound a little tighter with every passing turn, not pulled, not forced, simply carried along by gas that will not all move at one speed. As you rest, let the winding stay slow. It takes years to gather, deep beneath the surface, in a layer we have never seen and can only listen to. There is a gentle machine at work down there, made of hot gas, turning unevenly and rising in slow, twisting columns. And between them, they keep a magnetic field alive for billions of years. And so, the field winds patiently around the sun, turn after turn, resting quietly in the dark. Fact 64. That winding is what gives the sun its 11-year rhythm. Imagine the field gathering slowly, coiled tighter season after season, until loops of it drift up through the surface and show themselves as dark spots. Picture those spots arriving first at the higher latitudes, then appearing nearer and nearer the equator as the years pass, until the last few fade out and the surface goes plain again. Picture the whole thing beginning once more, unhurried from the top. As you rest, let this be breathing rather than weather, in and out, a cycle so long that a person can watch only 7 or 8 of them in a whole lifetime. There is no crisis anywhere in it, and no ending, only a field being wound up and then let out again, over and over. And so the sun keeps its slow 11-year breath, even and familiar, resting quietly in the dark. Fact 65. Young stars turn faster than old ones, and they slow in a way we can read as an age. Imagine a young star with a wind streaming off it, thin and constant, carrying a little of the stars turning away with it every year. Picture that wind held far out on long magnetic lines, so that even a thin breath of gas leaves carrying more turning than its weight suggests, and the star eases back a fraction, over and over, for billions of years. As you rest, take comfort in what that gives us. Measure how quickly a star turns today, and for most of its life you have a fair idea of how long it has been alight. There is a plainness in it. A star grows old the way anything turning grows old, giving its turning away by small amounts to whatever will take it. And so the stars wind slowly down as they age, gently and predictably, resting quietly in the dark. Fact 66. A star that turns quickly does not stay round. Imagine a ball of gas easing outward at its waist until it measures as much as a quarter further across the middle than from pole to pole, a shape more like a cushion than a ball. Picture the poles of such a star sitting deeper inside its own gravity, packed a little tighter and glowing a little hotter, while the stretched equator lies further out and shines cooler and softer. Picture that showing up as light, so the star is not one shade, but two, brighter at the top and bottom, softer around the middle. As you rest, notice what has quietly happened here. A movement has become a shape, and the shape has become a color, and nothing anywhere was pushed or built to make it so. There is nothing further needed to explain it, and so the quick turners hold their soft oval shape, lit unevenly, resting quietly in the dark. Fact 67. There is a limit to how fast a star can turn. Imagine easing that, turning upward, a little at a time, until the gas out at the equator is moving so freely that the star's own weight can barely keep hold of it. Picture that outermost layer resting there, almost weightless, held by the thinnest of margins, more inclined to drift away than to settle back down. As you rest, know that nature very rarely walks all the way up to that edge. Most stars sit far below it, and the few that do come close simply let a little of their material slip outward into a thin ring around themselves and ease back down again. There is no ending here, only a boundary, a quiet line, the way a shoreline is quiet, marking where one thing stops and another begins. And so, the stars turn well inside their limits, comfortable and unhurried, resting quietly in the dark. Fact 68. Two stars circling close together do to each other exactly what the Earth once did to the Moon. Imagine each one gently pulled out of the round by the other, carrying a slight bulge that always wants to point at its companion. Picture that bulge lagging a little behind as the star turns, rubbing softly against itself, taking a small amount of turning out of the star and handing it over to the orbit instead. Picture that going on for many millions of years, until each star turns exactly once for every circle it makes. As you rest, hold the ending of it. Two stars that have finally come to face one another, keeping the same side turned inward for the rest of their long lives. There is a stillness in that arrangement, for all that both of them are moving, and so the paired stars settle into step together, matched and unchanging, resting quietly in the dark. Fact 69. When a star reaches the end of its life and its core draws inward, nothing new begins. Imagine the same old rule simply carrying on. The turning that was already there has nowhere to go, so it has to fit into a smaller and smaller space. Picture a core that once came around perhaps once a week, drawn down to a fraction of its old size, and now coming around in a matter of seconds. Picture nothing added, nothing invented, nothing switched on. Only the same amount of turning, folded into less room. As you rest, let the arithmetic of it be the whole story. What looks from a distance like an extraordinary speed is only an old, ordinary movement kept in a smaller container. There is no drama anywhere in the calculation. And so the collapsed cores turn quickly for the plainest of reasons, gently and inevitably, resting quietly in the dark. Fact 70. A white dwarf is the leftover heart of a star, squeezed down to roughly the size of the Earth and left to cool for the rest of time. Imagine something that once took weeks to come around, now doing it in hours, and in some cases, in minutes. Picture that little glowing sphere, no bigger than the world beneath you, and holding over half the material of the sun, turning evenly in a place where there is nothing at all to slow it. Picture it dimming very slowly as the ages pass, and turning all the while at the same patient rate. As you rest, let the smallness be the comforting part. There is nothing of a wreck or a ruin about it. This is a star at the quietest stage of its life, keeping the turning it was given. And so the white dwarfs cool and turn together, unbothered and unwatched, resting quietly in the dark. Fact 71. A neutron star measures about 25 kilometers across, a body no wider than a small city, and most of them come around in a fraction of a second. Imagine standing far enough away to hold the whole of it in view at once. A smooth, dark sphere, the size of a quiet town, turning over and over without a sound. Picture how little there is to hear out there. No air to carry a noise. No surface rubbing on anything. No part of it loose enough to rattle. Picture that same movement holding hour after hour, year after year, with nothing to interrupt it. As you rest, let the smallness and the silence settle together. There is nothing here that strains. This is only an old star's core, keeping the turning it was handed, in a place with nothing at all to take it away. And so, the neutron star turns silently, even and unwatched, resting quietly in the dark. Fact 72. A pulsar is one of these small turning stars whose beam happens to sweep our way. Imagine a narrow cone of radio light leaving the star at an angle to its axis, carried around as the star comes around, the way a lighthouse beam is carried across the water. Picture that beam crossing the Earth once every turn, so what reaches us is not a steady glow, but a string of even pulses, spaced as regularly as a metronome. Picture the autumn of 1967, when a young researcher noticed such a signal in her chart paper and could not account for how tidy it was. Picture the name they gave that first one, half in earnest and half in fun, Little Green Men. As you rest, know that it was only a star turning. There is something warm in a mystery that comes out so ordinary. And so the pulses arrive on time, patient and countable, resting quietly in the dark. Fact 73. Some pulsars keep time as steadily over the years as the finest clocks we have built here on Earth. Imagine a pulse arriving, and the next one arriving, and the gap between them holding steady to within a tiny fraction of a millionth of a second, year upon year, with no one tending it. Picture astronomers using a scattered handful of these across the sky as a single instrument. They watch for the moment a pulse comes in a shade early or a shade late, and take that as a sign that the space between us has stretched very slightly. As you rest, let the scale of that be soothing rather than strange. These are the longest, slowest ripples anyone looks for, with single waves that take years to pass by. There is a patience in listening that way, one tick at a time. And so the pulsars keep the time of the universe, faithful and untended, resting quietly in the dark. Fact 74. The fastest pulsar we know of comes around 716 times every second. Imagine that number laid beside what is actually there. A body no larger than a small island, holding a rhythm so even that 20 years of watching have not caught it stumbling. Picture the beam arriving here as a steady hum rather than a series of flashes, too closely spaced for any eye to separate, and yet as regular as anything measured anywhere. Picture how little the object itself seems to notice, going about the same movement it has kept since long before anyone was here to point an antenna at it. As you rest, let the number stay in the background where it belongs. There is no display in it and no effort. It is simply a very small thing keeping a very old turning. And so, the quickest of them holds its rhythm, unbroken and soundless, resting quietly in the dark. Fact 75. The quickest pulsars did not begin that way, and they did not speed themselves up. Imagine one of them paired with an ordinary companion star close by, and a thin stream of gas easing across the gap between them over long ages. Picture that gas arriving with a turn of its own already in it, settling into a ring and then onto the little star, handing over a small share of turning with every load it delivers. Picture that going on for hundreds of millions of years until a slow old remnant has been wound gradually back up to speed. As you rest, notice that nothing was created anywhere in this. The turning simply changed hands, from one star to another, the way it always does. There is a quiet generosity in the picture, one star winding another. And so the recycled pulsars carry a turning that was never theirs, borrowed and steady, resting quietly in the dark. Fact 76. Once a pulsar is left to itself, it slows down, gently and steadily. Imagine its magnetic field reaching out into the space around it and carrying a small amount of energy away, and the turning easing back by the smallest amount to pay for it. Picture the interval between pulses growing longer, not by seconds in a year, but by fractions of a second across millions of years, so slowly that a lifetime of watching would show almost nothing. Picture too the rare little hiccup when a pulsar comes around a shade quicker than expected, as something deep inside it settles into a slightly different arrangement, and then the gentle drift resumes. As you rest, let the ending be soft. A pulsar does not end in any sudden way. It simply turns more and more slowly until its beam fades out of earshot. There is nothing lost in that. And so the pulsars wind down across the ages, quietly and without complaint, resting quietly in the dark. Fact 77. Material cannot fall straight into anything while it is still carrying a turn. Imagine gas drifting inward towards some small, heavy object and finding that it cannot reach the middle. The turning it brought along holds it out, and it settles into a wide circle instead. Picture that gas joining with more gas, and the whole gathering flattening into a thin disk in exactly the way a cold cloud flattens into a disk. Picture each parcel rubbing very gently against its neighbors, passing a little of its turning outward to them and easing inward by one small step each time it comes around. As you rest, let that be the whole of the mechanism. This is not a fall, but a slow spiral, many thousands of circles for every step inward. There is patience built into the shape itself, and so the disk turns and narrows, ring by ring, resting quietly in the dark. Fact 78. A turning black hole has no surface, so there is nothing there that could be turning in the ordinary sense. Imagine instead that the space itself is taken up in the movement, drawn gently around, the way water is drawn around by a slow stir. Picture a region just outside it, where that carrying is strong enough that nothing at all can stay in one place. A ship out there could point whichever way it liked and hold perfectly still, and it would be carried around anyway, evenly, along with all the space around it. Picture how quiet that is. No wind, no push, nothing to feel, nothing to resist. As you rest, let the strangeness be restful rather than unsettling. There is nothing at all being done to anyone there, and no effort involved anywhere in any of it. And so the space itself turns, smooth and unhurried, resting quietly in the dark. Fact 79. The same thing happens around the Earth, far too faintly for anyone to feel. Imagine the ground beneath you, carrying the space around it very slightly along with it as it turns. The way a hand turning slowly in honey draws the honey around. Picture a satellite sent up to look for exactly that, holding 4 spheres so nearly perfect that if one was scaled up to the size of our planet, its highest hill would stand only a couple of meters tall. Picture those spheres set turning and then left alone for a year, and their axes found afterwards to have shifted by no more than the width of a hair held up at the far end of a long street. As you rest, take that as the gentlest measurement anyone has made. There is a real tenderness in work as careful as that. And so the space around the Earth turns along with it, faintly and almost imperceptibly, resting quietly in the dark. Fact 80. We cannot watch a black hole turn, so we read its turning from the things around it. Imagine looking for the inner edge of the disk, for how close the material can come before it can no longer hold a steady path. Picture that edge lying nearer in around a quick turner and further out around a slow one, so that the width of a gap quietly becomes the measure of a movement. Picture what the turning does with what it gathers. 2 narrow streams leaving along the axis, holding their aim, as far as we know, for longer distances than anything else in the sky holds a line. As you rest, notice the pattern once more. A turn makes a disk, the disk makes an axis, the axis makes a line. There is nothing more to it than that. The wider the scale, the slower the movement becomes. And so the turning sets the direction, steady and far-reaching, resting quietly in the dark. Fact 81. We are moving as well. The Sun, and the Earth along with it, travels around the center of the galaxy at something close to 230 kilometers every second. And it has done so without pause for its whole life. Imagine a number like that, and then set it against the distance it has to cover, and it becomes almost nothing at all. Picture the night sky as it looked 100 years ago, and 100 years before that. The same patterns in the same places, entirely unchanged by all that traveling. As you rest, there is nothing here to brace against, no wind, no sensation, no direction you could point to and call forward. There is something steadying about a motion so large that a whole human life leaves it looking exactly as it was. The galaxy takes its time with us, and so we are carried around with it, even and unhurried, resting quietly in the dark. Fact 82. One turn around that center takes somewhere near 230 million years, and the estimates do not all agree. So you may also see it given as a little more or a little less. Imagine a single lap that begins and ends so far apart in time that nothing alive at the start could still be there at the finish. Picture the Sun tracing it out, patient and unvarying, laying down the same wide curve it has laid down many times before, never once straying from it. As you rest, there is no need to hold on to any of these figures. This is simply what a year looks like when it is measured by the only clock large enough to keep it. There is comfort in a calendar page that turns as slowly as this one does, and asks nothing of anyone while it turns. And so, The long lap goes on, steady and unfinished, resting quietly in the dark. Fact 83. The last time the sun stood where it stands tonight, the first dinosaurs were only beginning to appear here on Earth. Imagine that as the length of the journey, rather than any figure at all. One full circuit of the galaxy, measured out in the whole history of an animal family. Picture everything that has happened on this planet since then. The oceans rearranging themselves, the mountains rising and wearing away again, the ice arriving and leaving and arriving once more. All of it fitting inside a single quiet lap. As you rest, let that be the scale of things for a moment. A turn so long that history is one of its smaller details. There is something restful in belonging to a movement that was well underway long before anything here could notice it. Nothing had to be arranged. It simply carried on. And so the great slow circuit continues, older than every creature on it, resting quietly in the dark. Fact 84. All of it is happening at once, in the same place, underneath you. Imagine the ground going round its own axis through the night, and the whole planet going round the sun through the year, and the sun going round the galaxy through an age far longer than either. Picture them nested inside one another like rings, each one steady, each one indifferent to the others, none of them ever interfering with the rest. As you rest, you are riding all of them together, and not one of them asks anything of you or gives the slightest sign that it is there. There is something quietly companionable in that. A body lying perfectly still while three separate circles are drawn around three separate centers beneath it. You have never once had to keep up. And so the wheels turn inside one another, gentle and unhurried, resting quietly in the dark. Fact 85. A galaxy does not turn the way a record turns. Out at the edge, far from all the crowded light of the middle, the stars move around almost as quickly as the stars near the center do, when, by everything we can see and weigh, they ought to be drifting along much more slowly. Imagine a carousel where the outer horses keep pace with the inner ones, calmly, without any visible reason for it. Picture the measurement itself, a long line of little velocities read off across the width of a galaxy and coming out flat where they were expected to fall away. As you rest, nothing has gone wrong here. It is simply a curve that did not bend the way anyone thought it would, and it has stayed unbent ever since. There is something honest in a result like that. And so the outer stars go round in their own good time, patient and unexplained, resting quietly in the dark. Fact 86. That flat curve was measured by Vera Rubin and Kent Ford, working through the 1970s with a spectrograph and a great deal of care. Imagine the two of them at a mountain observatory, night after cold night, taking the light of one galaxy and spreading it out to read how fast each part of it was going. Picture the slow accumulation, one galaxy and then another, until the same quiet shape had appeared so many times that it could no longer be a fault in the instrument. As you rest, there is something lovely in a discovery made this way, without any single dramatic evening, simply by looking carefully for years and writing down what came back. There is peace in work that arrives at its answer gradually and lets the answer settle on its own. And so the galaxies were measured one by one, unhurried and thorough, resting quietly in the dark. Fact 87. The most widely accepted explanation is that a galaxy is held together by a great deal of matter we cannot see, spread out in a soft halo far beyond the visible stars. Imagine something that gives no light of its own and takes none away. and shows itself only in the way the outer stars keep pace. Picture it as the leading idea and not the only one. Some would rather adjust the rule of gravity itself, where its pull is this weak. As you rest, it is enough to say that this remains one of the things we do not yet understand. There is something restful about an unfinished answer that has stayed unfinished for 50 years and is in no hurry whatsoever to become anything else. And so the question sits where it was left, open and untroubled, resting quietly in the dark. Fact 88. The spiral arms are not spokes on a wheel. If they were fixed to the stars they contain, the inner parts of each arm would come round faster than the outer parts, and over a few billion years, every arm would have wound itself into a tight coil. Imagine instead a slow ripple traveling through the disk, a region where the stars and gas crowd together a little more closely as they pass through it. Picture a slow bend in a river where the water gathers and thickens, holding the same shape year after year, while every drop that arrives passes through it and drifts on out the far side. As you rest, that is what an arm is, a pattern rather than a thing, drawn in light because the crowding makes new stars. And so the bright arms hold their shape while the stars pass through them, patient and unchanging, resting quietly in the dark. Fact 89. Across the middle of many spirals, our own included, there is a long straight bar of stars, and it turns as one piece at its own rate, separate from the disk around it. Imagine a slow paddle set across the center of a wide pool, going round and round while the water outside it drifts at its own speeds. Picture what such a shape does over time. Gas that comes near it is nudged out of its easy circle and eased gradually inward, a little on each pass, gathering towards the middle over hundreds of millions of years. As you rest, there is nothing sudden in this, only a soft, persistent stirring that never stops and never hurries. There is something homely about a galaxy quietly tidying itself, moving its own furniture inward across an age, with no one waiting on the result. And so, the great bar goes round at its own pace, gentle and unbothered, resting quietly in the dark. Fact 90. The black hole at the center of a galaxy is not what makes the galaxy turn. Imagine how far away the outer stars are from that middle, and how little of anything reaches across such a gap. Picture the pull of that central mass fading with distance until, out where we are, it counts for almost nothing against the weight of all the ordinary stars and gas spread through the disk. As you rest, the turning out here was inherited from the cloud this galaxy settled out of long ago, and it has simply been kept ever since. There is something reassuring in that, a center that holds no reins at all, and an outer disk that keeps going round for reasons that were settled long before it, and entirely its own. And so the far stars circle without being led, calm and self-possessed, resting quietly in the dark. Fact 91. Not everything in a galaxy joins in the turning. The old globular clusters and the scattered stars of the halo far above and below the disk take no real part in it. Imagine a wide, flat wheel of light with a loose swarm of much older things drifting all around it, coming in from every direction at once. Picture their paths, long and stretched out, falling inward and rising away again on tilted orbits with no shared direction between them, so that added together they very nearly cancel. As you rest, this is worth noticing because it is an honest exception. Almost everything turns, and here is something that does not, spread around the disk in a quiet, unsorted cloud that has never been asked to line up. There is room in a sky like this for both. And so the halo drifts without a common direction, loose and unhurried, resting quietly in the dark. Fact 92. There are whole galaxies that barely turn at all. In the largest and roundest of the elliptical ones, the stars move in every direction, up and down and across, each on its own tilted path. And the sum of all that movement leaves almost no overall rotation. Imagine a swarm of bees holding its shape in the air without circling anything, held up simply by the movement of its own members. Picture such a galaxy from the outside, smooth and featureless and softly glowing, keeping its rounded form for reasons that have nothing to do with turning. As you rest, notice how gently the rule bends here. Shape can be held by order, as it is in a flat disk. Or it can be held just as well by disorder. There is no strain at all in either one of them. And so the round galaxies hold themselves without turning, still and self-supporting, resting quietly in the dark. Fact 93. Go one step wider still to a cluster where many galaxies drift together, and the turning has thinned out almost entirely. Imagine them moving slowly through and past one another in a loose gathering, drawn inward, then out again, with no shared direction anywhere in it and no common axis to speak of. Picture how differently this behaves from a disk, which is a settled thing, and how a cluster is instead a gathering that has never fully settled and has had nowhere near enough time to do so. As you rest, the larger the scale you look at, the less shared turning is left in it, until at last there is none worth naming at all. There is something calming about a rule that quietly weakens with distance instead of breaking outright. And so the great gatherings drift without a direction, slow and unsettled, resting quietly in the dark. Fact 94. There are faint hints that the axes of neighboring galaxies are not quite randomly arranged, that they lean a little in step with the long threads of matter they formed within. Imagine a field of grass leaning very slightly the same way, so slightly that you would have to measure a great deal of it before you could be sure the lean is really there. Picture the work involved in such a claim. Galaxy after galaxy sorted by orientation, and the effect coming out small enough that careful people disagree about whether it is there at all. As you rest, this is a place where we are honestly still looking, and where the answer may well take another generation of patient measuring to arrive. There is nothing here that needs to be decided tonight, or soon, or by anyone at all. And so the faint tendency is watched and remeasured, quiet and unconfirmed, resting quietly in the dark. Fact 95. There is a plain reason that turning fades away at the largest scales, and it is the same rule as ever. Turning is inherited. A thing spins because it drew itself together out of something that already carried a little turning, and the shrinking made that turning plain. Imagine any turning body at all, and the same story sits behind it. A cloud that contracted, a leftover motion that had nowhere else to go. Picture then the largest scales of all, where nothing ever drew together in that way, and nothing ever shrank. As you rest, there is simply nothing there for a turning to be inherited from, and so, very softly, there is no turning at all. There is a particular kind of quiet in that, and so the greatest scales hold still, with no turning of their own, resting quietly in the dark. Fact 96. As far as we are able to measure, the universe as a whole is not turning. Imagine adding up every rotation there is. The dust and the moons and the planets and the stars and the galaxies, each with its own direction, all of them pointing in different ways. Picture what that sum comes to when the last of it is gathered in, as near to nothing as we can measure. There is no great wheel outside all of this carrying the rest around. One piece of work does gently ask whether some faint trace might still be hiding there, a turning so slow that a single revolution would take hundreds of billions of years, but it is put forward as a question and not as an answer. As you rest, nothing about it needs settling. And so the question waits patiently for better measurements, open and unhurried, resting quietly in the dark. Fact 97. And to give that idea its proper size, even if such a turning were really there, then across the whole age of the universe, from the very beginning until tonight, it would have turned by less than 3/100ths of a single turn. Imagine a clock hand that has barely cleared the first minute of its very first hour and has all the time there is to take the next one. Picture how little would have changed in all that time, and how nothing anywhere, in all of it, would ever have felt it happen. As you rest, let that stay a possibility and nothing more. There is something deeply peaceful in the thought of emotions so slow that the entire history of everything would not be enough to complete a lap. Nothing needs to be remembered here. And so even that suggestion would barely begin, faint and unfinished, resting quietly in the dark. Fact 98. None of this will stop by itself. In the emptiness between things, there is no friction to speak of, nothing to rub against, nothing to wear a movement down. Imagine a turning that began before there was a sun and has never needed anything at all to keep it going. Picture how a turning actually ends, when it ends at all. Not by stopping, but by being handed on, a little at a time, to a tide, to an orbit, to a companion, over ages so long that the handing is invisible. As you rest, that is the whole of it. Nothing is lost anywhere in this. Everything that turns tonight has been turning for a very long time and will still be turning long after tonight has gone. There is nothing to hold up and nothing to keep going. And so it all continues without effort, endless and undisturbed, resting quietly in the dark. Fact 99. It is one movement at every size. A grain of dust in a cold cloud, turning where no one can see it. A moon keeping one face towards its planet. A world carrying its oceans around an axis it never chose. A star, and then the small, dense thing a star leaves behind. Space itself drawn slowly around something heavy. And a galaxy taking an age to come around once. Imagine them set side by side, all these different sizes, all doing the same thing. Picture how none of them makes any sound at all, not one, from the smallest to the largest. As you rest, there is nothing further to add. The same gentle inheritance runs through every step of it, handed down and down until it reaches the room you are lying in. And so all of it turns together, quiet and unbroken, resting quietly in the dark. Fact 100. And the last of it is beneath you. While you lie there without moving, the ground is carrying you round, the way it has carried everything on it every night there has ever been. Imagine the room turning very slowly with you inside it. The walls, the window, the dark outside, all of it going gently on together. Picture how little is required of you for this to happen, how it has never once needed your attention or your permission. As you rest, you can let go of all of it. Not one of these turnings asks anything of you. There is nothing here to hold on to, nothing to check on, nothing at all to finish before the morning comes. The turning will look after itself tonight, as it has looked after itself every other night. And so you turn with the world, warm and unhurried, resting quietly in the dark. Sleep now. And so it all keeps turning, the way it has since long before the sun was lit. Nothing pushes it, nothing stops it. The dust turns, the moons turn, the galaxies turn, and none of it makes a sound. Somewhere, a cold cloud is still settling into a disk and will still be settling long after tonight. Somewhere, a moon is easing a little further out from its planet, so gradually that nothing there will ever notice. None of it is in a hurry, and none of it is waiting for you. The ground beneath you is turning too, gently, carrying you with it, as it has all your life, without once asking to be noticed. There is nothing left to do tonight, and nothing you need to remember. Let your breathing slow. Let the thoughts settle where they fall. Rest now. It will all keep going without you, quietly, and it will still be turning in the morning. Sleep well.